This is the part 2 section. Here I'm going to start with vector. So vector, you know, by definition, vector it is equal to magnitude and direction. So a vector, that means it is represented as small letter a and arrow is given at the top. So a vector is equal to magnitude of a into a cap. What is a cap? It is a unit vector which gives the direction. So here, as per our definition, vector that is equal to magnitude and direction. This is the main basic of vector. Now, there are two laws are given for vector addition. One is the triangle law and another is the parallelogram law. Uh, the result of the according to the triangle law, the result of the sum of any two vector is called the resultant vector. And in case of parallelogram law, the diagonals of the parallelogram gives the resultant of the any two vectors. That means the two vectors must be the arms of a parallelogram, then the diagonal will give the resultant vector. So this is the very basic of a vector. Now this vector, it has been merged with the coordinate geometry. So here you see that in two dimension, let us consider in two dimension, that is in xy plane. If you take a point P in the xy plane and let the coordinate of P be 2 comma 3. So along the x-axis we move 2 units, and then along y-axis we moved 3 units. So this is represented as the movement along x-axis 2 units. It is represented as 2I cap, and the movement along y-axis that is 3 unit. It is represented as 3j cap. So here OP is your resultant vector, and this OP resultant vector is equal to 2I cap plus 3j cap, where I cap and j cap are the position vector, are the unit vectors, where I cap and j cap are the unit vectors, and OP vector is called the position vector, where this direction of OP is always outward. Remember this, very important. This I am telling you in two dimension. That is your OP vector, that is the any vector which originates from origin is called the position vector, and the position vector here is the resultant vector, and this position vector OP vector is equal to 2I cap plus 3j cap. And magnitude of OP, which will get from the Pythagoras theorem, that is equal to root over 2 square plus 3 square. So what is the conclusion? That in xy plane we take a point P whose coordinate is x and y. So your OP, your position vector, is equal to xi cap plus yj cap. It represents two things. If the position vector OP is written as xi cap plus yj cap, then x and y are called the coordinates of the point P. And if the coordinate of the point P is given to you x and y, then your position vector OP vector is equal to xi cap plus yj cap. Now we extend to three dimension, because in your book it deals with three dimension. In case of three dimension, we get x, y, z axes. The unit vector along x axis is called I cap, along y vector it is j cap, and along z axis it is k cap. So any point P on the space whose coordinates are x, y, and z, your position vector OP vector will be the resultant vector, and this OP vector is equal to x I cap plus y j cap plus z k cap. And the magnitude of OP vector, that will be equal to root over x square plus y square plus z square. So this is the relation between the vector and the coordinate system. Now here comes our product rule, that is the dot product, that scalar dot product and vector cross product. The scalar dot product is the product of two vectors, which is also called as dot product, and the result is a scalar. So it is called a scalar dot product. And A vector dot B vector, that is equal to magnitude of A vector into magnitude of B vector into cos theta, where theta is the angle between the two vectors A and B. And from this formula, we can also find out. So here, theta, it is the angle between the A vector and B vector. So this is about your dot product. And if we merged with the coordinate system, so your A vector, that will be equal to a1 I cap plus b1 j cap plus c1 k cap, and your b vector will be a2 I cap plus b2 j cap plus c2 k cap. So a vector dot b vector will be equal to a1 a2 plus b1 b2 plus c1 c2, because we know that I dot I, so I dot I, that is equal magnitude of I in dot magnitude of I cos 0, because the angle between the uh, between 2I will be 0, which represents the x-axis. So your magnitude will come to 1, and I dot j will be 0, because the angle between I and j, x-axis and uh, y-axis, it is 90 degrees. So cos 90 is equal to 0. So I dot j will be 0. So your A vector dot B vector will be equal to A1 A2 plus B1 B2 plus C1 C2. Now here comes the uh, formula in coordinate system. If you go for in coordinate system, we know that A vector dot B vector is equal to magnitude of A vector into magnitude of B vector, and cos theta. Theta is the angle between the two vectors. So your cos theta will be equal to A1 A vector dot B vector by magnitude of A vector dot magnitude of B vector. Now, if we take A vector is equal to A1 I cap plus B1 j cap plus C1 k cap, that means that the coordinate of is A1, A2 and B1, and another vector, that is B vector, it is A2 I cap plus B2 j cap plus C2 k cap, that means the coordinates are A2, B2 and C2. So your cos theta will be equal to A vector dot B vector by magnitude of A dot magnitude of B. So this will come out to be A1 A2 plus B1 B2 plus C1 C2 by root over A1 square plus B1 square plus C1 square dot root over A2 square plus B2 square plus C2 square. Now here you see, if the angle between the two vector is 90 degrees, so cos 90 will be 0. So here it comes A1 A2 plus B1 B2 plus C1 C2 will be equal to 0. Now before telling this, I must tell you something. It will be better. I should have explained it. Something is left here. Here, that is um, directions cosines. What is directions cosines? The position vector OP, which makes an angle alpha with x-axis and beta with y-axis and gamma with z-axis. So cos alpha, cos beta, cos gamma, they are called the directions cosines. And cos alpha is represented as L, cos beta is represented as m, and cos gamma is represented as n. Now let us consider A, B, C, which are proportional to these directions cosines are called the directions ratios. So L is proportional to A, M is proportional to B, and N is proportional to C. Now from here we derive a relation between the directions cosines and directions ratios, that is L is equal to A by root over plus minus root over A square plus B square plus C square, and m is equal to b by plus minus root over a square plus b square plus c square, and n is equal to c by plus minus root over a square plus b square plus c square. This is the relation between directions cosines and directions ratio. And one of the important point here is that cos square alpha plus cos square beta plus cos square gamma is equal to 1. That means L square plus m square plus n square is equal to 1. So here the most important point is that the position vector OP, which makes angle alpha with x-axis, beta with y-axis, and gamma with z-axis, if this cos square alpha plus cos square beta plus cos square gamma is equal to 1, then this cos alpha, cos beta, cos gamma are called the directions cosine. Remember this. So if an OP vector, if you write an OP vector is equal to 2 I cap plus 3 j cap plus 4 k cap. Now this 2, 3 and 4, if 2 square plus 3 square plus 4 square is equal to 1, then only 2, 3 and 4 will be the directions cosines, other it will be directions ratios. This is the very important point here. Then it will be directions cosine, otherwise it will be directions ratios. Now let us consider 2 point in space, that is we are considering three dimension x, y, z, and we are considering 2 points in space. Point A whose coordinate is x1, y1, z1, and point B whose coordinate is x2, y2, z2. So here your OA is the position vector, OB is the position vector. Now we are going to find AB vector. So we know that the directions of the position vector is always outward. So OA vector and OB vector, it will be outward. Now you have to find out, we have to find out the AB vector. So we know that OA vector, that will, since the coordinate of point A is x1, y1, z1. So your OA vector is equal to x1 I cap plus y1 j cap plus z1 k cap. And your OB vector is equal to x2 I cap plus y2 j cap plus z2 k cap. Now when you apply the triangle law, that means your AB vector will be x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So here x1 minus x2 minus x1, y2 minus y1, z2 minus z1, they are called the directions ratios. Remember that your AB vector will be how much? X2 minus x1 I cap, y2 minus y1 j cap, and z2 minus z1 k cap. So here x2 minus x1, y2 minus y1, and z2 minus z1, they are called the directions ratios. Now we go move to there is one more thing I have not yet told you, that is projection of A vector on B vector. That means projection of A vector on B vector. That means you are bringing the A vector in the direction of B vector. So this A vector dot B cap. And we know that B cap, that is B vector, is equal to magnitude of B into B cap. So B cap will be equal to B vector divided by magnitude of B. So A into B cap, we know that B cap is B vector divided by magnitude of B. So A into B cap, that will be A into B vector divided by magnitude of B. Similarly, projection of B vector on A vector, that means we are bringing the B vector in the direction of A vector. So B vector dot A vector. B vector dot A cap means, that means we are bringing the B vector in the direction of A vector. So we are bringing, so your b vector dot a cap, and this a cap that will be equal to a vector divided by magnitude of a. So b vector dot a vector divided by magnitude of a. This is the projection of b vector on a vector. Now here we move to and that is your we move to this cross product. So here cross product, that is a vector cross b vector, is equal to magnitude of a vector into magnitude of b vector into sine theta into n cap, where n cap, it is a unit vector whose direction is perpendicular to the plane containing a and b, and theta, it is the angle between a vector and b vector. So to solve A cross B vector, we use determinant method to solve A cross B. The most important in a dot product is that dot product, it follows the full algebra, because A dot B is equal to B dot A. It follows the commutative property, it follows associative property. So there is no problem with the dot product. Only the problem with is with cross product, because a vector cross b vector is not equal to b vector cross a vector, because the cross product of two vector is a vector. And so to solve the cross product, we use the determinant method. Now next important point here is that the magnitude of a cross b vector is equal to the area of a parallelogram. So this is all about your vectors and relation. It has been related with coordinate system and position vectors and directions cosines and directions ratios. This is all. So now the most important point is that if a vector, it is given to you, that is 2 I cap plus 4 j cap plus 6 k cap, then this 2, 3, 4, they are the directions ratios, remember. If your 2 square plus 3 square plus 4 square is equal to 1, then only you can say that 2, 3, 4 are the directions cosines. Now we move to the equation of a straight line. That is the equation of a straight line in it is given in vector form as well as in Cartesian form. In vector form, that means the condition given to you, that is the line which passes through a point A, and its coordinates are x1, y1 and z1, and it is parallel, and that line is parallel to a B vector whose directions ratios are given to you, that is B vector is equal to AI cap plus BJ cap plus CK cap. So here we know that our most important point is that if a vector is parallel to another vector, then remember that if you can prove that a vector is some scalar multiple of b vector, then your a vector will be parallel to the b vector. So here again, your a vector, your this line is parallel to b vector. So first of all, we are going to find out the vector form of this line. So this line is passing through point A, whose coordinates are given x1, y1, and z1, and we are considering an arbitrary point B, which coordinates are x, y, and z. So here your AB vector, using triangle law, your AB vector will be equal to your yeah, AB vector, that will be equal to, so your A vector, we the point A we join with origin, so this vector OA, this is the position vector, and this OA vector we represent as small a vector, and the arbitrary point B, we join that B with the origin, this position vector with represented by r vector, small letter r vector. So your AB vector will be equal to r vector minus a vector. Now since your B vector is parallel to AB vector, so it is given to you, so B vector will be equal to some scalar multiple of, that means your AB vector will be some scalar multiple of B vector. And your A vector is we have find it out r vector minus a vector, that is equal to lambda b, scalar multiple lambda b. So your r vector will be equal to a vector plus lambda b vector. So this is the vector form of the equation of the straight line. Now if you convert this into Cartesian form, it will be x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c, where x1, y1, z1, it is the point through which the line is passing, it is given to you, and a, b, and c are the directions ratios of b vector which is parallel to the given line. So these things you must remember. And now the angle between two vectors, this is determined by the angle made by the two parallel vectors b1 and b2. The angle made by them is the same angle made by the two lines. So your cos theta, the b1 vector, let us consider as a1 I cap plus b1 j cap plus c1 k cap, and b2 vector is equal to a2 I cap plus b2 j cap plus c2 k cap. So here here the angle between the two vectors will be b1 vector dot b2 vector is equal to magnitude of b1 vector into magnitude of b2 vector into cos theta. So cos theta will be equal to b1 vector dot b2 vector by magnitude of b1 vector into b2 vector. So here the results comes out, your cos theta will comes out to be a1 a2 plus b1 b2 plus c1 c2 divided by root over a1 square plus b1 square plus c1 square dot root over a2 square plus b2 square plus c2 square. When the two vectors are when this b1 and b2 vectors, if the angle between them is 90 degree, then your a1 a2 plus b1 b2 plus c1 c2 is equal to 0. And if the lines are parallels, then it will be a1 by a2 equal to b1 by b2 equal to c1 by c2. Now, what is the distance between two skew lines? Remember that the two skew lines, the two lines are different in different planes. Remember that when two lines are different planes, they will never intersect each other. Remember that they will never intersect each other. The lines intersect only when they are in the same plane. The line intersect when only when they are the same plane, and the distance between the two skew lines, that will be the result is modulus b1 vector cross b2 vector dot bracket a2 minus a1 vector divided by magnitude of b1 vector cross b2 vector. So this is the distance between two skew lines. So these all formulas and everything and the diagrams must be clear to you, and the every terms must be clear to you. Then only you will be able to solve the problem. Now let us shift to this uh, different this inverse trigonometry. So here your inverse trigonometry, it is an inverse function, and this inverse function, that they are cos sine inverse x, cos inverse x, tan inverse x. These are the inverse function. So here in inverse function, you must remember the graphs. And whenever, that means the main important point is that when you are finding inverse, when you are finding inverse the inverse function, it gives you the angle, it gives you the angle, such as sine inverse 1, it is equal to 90 degree. So here in inverse function, what happens, y is equal to sine x. In this y is equal to sine x, when we it becomes inverse function, then what happens, the domain of sine x becomes the codomain in sine inverse x, and uh, uh, and the your codomain becomes the domain in sine inverse x function. So I have already told you that when you find uh, the value of any inverse function, that means the you are finding the angle. So here, while finding the angle must be principal value. The angle must be principal. Remember that while finding the angle must be the principal value. Principal value, which is I have already told you, that is it is value must be greater than equal to 0 and less than 2 pi. So you have to remember that the principal value of sine inverse x is minus pi, close interval minus pi by 2 to pi by 2. Similarly, for your cos is close interval 0 to pi. Similarly, for tan inverse x, open interval minus pi by 2 to pi by 2 to 2. So this is the most important point you must remember. The graph and the uh, principal value, you must remember this, and your angle must be within this principal value. So now there are other formulas also, like sine inverse x into sine is equal to x. Similarly, cos inverse x into sine inverse x into sine x is x. Cos inverse x into cos x is x. Tan inverse x, sorry, let me tell you again, sine inverse x, not sine inverse sine x. Let me tell you again, remember this, sine inverse sine x is x, cos inverse cos x is x, tan inverse tan x is x. There are other formulas also, such as your sine inverse x is equal to cosec inverse 1 by x, cos inverse x is equal to sec inverse 1 by x, and tan inverse x is equal to cot inverse 1 by x. Similarly, you must remember that sine inverse minus x is equal to minus sine inverse x, cos inverse minus x is equal to pi minus cos inverse x, and tan inverse minus x is equal to minus tan inverse x. And other formulas, there are also other formulas, that is your sine inverse x plus cos inverse x is equal to pi by 2. Similarly, sec inverse x plus cosec inverse x is equal to pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2. There are also other formulas, that is your tan inverse x plus tan inverse y, that is equal to tan inverse x plus y by 1 minus xy, and tan inverse x minus tan inverse y is equal to tan inverse x minus y by 1 plus xy. And their conditions for this formula, conditions are given. You must remember this condition, and while solving this formula, while solving it, you must follow the conditions which are given to you. Again, there is a relations between your mm, relations between the sine inverse and tan inverse, and your that is your uh, there is also relation between your tan inverse x and sine inverse x, tan inverse x and cos inverse x. These relations, and these relations you must remember. So here is all this about your inverse function. The main important point in inverse function, that whenever the inverse function is given to you, on the side of the question you will find that the a condition will be given to you, and you must follow this condition, and according to this condition you must solve the problem. Now we go to your our this uh, function, and there is one function and relations in your class 11, that is 12, your function, that is 1 function and onto function. Means 1 function, that means for for a value or in your domain, there will be an unique value in codomain, then it is called 1 function. Otherwise it will be a mini one function. So for 1 function, the To express it is that let x1 and x2 we have taken it, and if fx1 is equal to fx2 implies that x1 is equal to x2, then it is a one-one function. Let me explain you by the help of an example. Suppose your function is a real value function, f r to r. Real means your domain is real number and your codomain is real number, and the function taken is y is equal to x square. So here let us take x1 is equal to 1 and x2 is equal to minus 1. Here we find that fx1 is equal to fx2 because plus 1 square is also 1 and minus 1 square is equal to also 1. But 1 is not equal to minus 1. Then we say that it is not a one-one function, it is a many-one function. In case of one-one function, let us take this the same function, but we are going to redefine your function, that is natural number to natural number. When we redefine it to your domain is natural number and your codomain is natural number, then your y is equal to x square. This will be one function because x is equal to, if you take x1 and x is equal x1 is equal to 1, x2 is equal to 2. Here the fx1 will be never equal to fx2. At the same time, since it's a natural number, we can take only one, we can't take minus one. So this is called uh, one function. In one function, the most important is that it is given stress to the domain. That means for every value of domain there must be a distinct value in codomain. In one function, the stress is given to domain, that is for every value of for every value of the domain there must be a distinct value in the codomain. And at the same time, while analyzing it, you must also see that the function it is r to r or n to n or n to z or z to z. You must also look at it, because this is also the controlling factor when whether it is a one or onto, whether it is one or many one. And next is the onto function. In the onto function, it is that for every value of codomain, there must be a value in domain. For every value of codomain, there must be a value in codomain, that is fx is equal to y. And here in onto function, the stress is given, on in your codomain. So remember, these are the basic points which you must remember. And in relations, there are again here relations that is reflexive, symmetric, and transitive. This is a little bit, as per definition, your reflexive is very easy. That is in reflexive, the ordered pairs in the relation set, your ordered pairs must be AA. That means if you let A set, and in this reflexive, symmetric, and transitive, the most important point here is the relation is between the same set A to A. Your domain is A and your codomain is also A. And in case of reflexive, your the order pair must be AA. That means for every value of the elements of the given set capital A. So let me explain it by the help of an example. Let us consider a set A whose element is 1, 2, and 3. So the relation will be reflexive if the relation set contains 1, 1, 2, 2, 3, 3. If it contains 1, 1 and 2, 2, but there is no 3, 3, then it will be not reflexive. So for every value of set A, there must be an ordered pair, that is AA. Then only it is called reflexive. And in case of symmetric, that is if AB belongs to the relation set, which implies that BA belongs to the relation set, then it is symmetric. And the third is that transitive, that is transitive, that is if let AB belongs to the relation set and BC belongs to the relation set, then your AC also belongs to the relation. then we say that it is transitive. And the set which satisfy all these three conditions, we call this as an equivalence relation. In spite of it, you must remember some special cases. If a set A is equal to 1, 2, 3, 4, then if the relation set is 1, 1, 2, 2, and 3, 3, then 3, 3, and 4, 4. It is no doubt reflexive, but it is the smallest equivalence relation. Remember this. This is the smallest equivalence relation. And again, if the relation set contains only one order pair, like 2 2, only if it contains only one order pair 2 2, the then it will be symmetric and transitive but not reflexive. Similarly, if the relation set contains only 2 and 3, order pair 2 3, 2 3, then it will be transitive. Remember, these are the special cases uh, uh, in your reflexive, symmetric, and transitive. Now let us move to I do not want to deal with matrices, but the most important point in matrices, the formula used is that A dot A inverse is equal A dot A inverse is equal to identity matrix. This is used in many cases to solve the problems. Remember that A dot A inverse is equal to I. This is used in many cases to solve the problem, and some of the, that is a transpose. In case of transpose, that means when you transpose a matrix, that means you the row is converted to column. The row is each row is converted to column. We call this as a transpose matrix. And there are some important properties in transpose. That transpose A dot B, the whole transpose is equal to B transpose dot A transpose, and A B to A A plus B to the whole power transpose is equal to A transpose plus B transpose. This is the very important property. And here now next is the symmetric matrix and the skew symmetric matrix. In symmetric matrix, your A is equal to A transpose, and in your skew symmetric, that is A transpose is equal to minus A. And in skew symmetric, remember, your diagonal elements must be zero. Remember that your diagonal elements must be zero. These are some of the important point. And again, if A and B are symmetric, it is mm, product of A and B will never be symmetric. Remember this. So here, such type of properties you must remember in matrices, which is very important. And determinants here determines here. There are some properties in determinants, that is uh, uh, these are, that means yeah. First of all, you must know the expansion, how to expand a determinant. That is very easy. And there are some law properties, that is row and column properties. That means like such type of properties, that is R1. In R1, you can do R1 plus R2 plus R3. And R1 you can do R1 plus 2R1, 2R2. So such you can even interchange. That is, if you interchange a row, then your determinant will be minus. Suppose if you interchange R1 to R2 to R1 and R1 to R2, then your determinant will be negative. So such type of property you must uh, remember. So this is all about your uh, matrices. This is all about your matrices and determinants. In matrices, small questions are asked, and for this, there are some other properties also which you must remember. And one of the most important property in matrices, while you multiply it, that is uh, uh, if a matrix is of order m into n, and another is of order matrix is of order n into p, then after the product the order will be m into p, first and last. Remember that it will be first and last, m into p. So this order of the matrix is very important. But in your textbook it is limited to 3 cross 3 matrix only. And again, formulas are given to find out inverse matrix, that is to find out inverse matrix, that is adjoint of A divided by modulus A. In finding the adjoint of A, what we go, we first of all find the cofactors, and after finding the cofactor, we transpose it. When we transpose the cofactor, we get adjoint of A, and this adjoint of A divided by the determinant A, we get the A inverse. So, and the most important point is here is that if determinant A is 0, then it is singular matrix, and if it is determinant A is not equal to 0, then it is non-singular matrix. And the very important point here is when A inverse, that is adjoint of A by determinant A, and if your determinant A is 0, then it becomes inconsistent. And if your determinant A is not equal to 0, then it is consistent. That means you are going to get the value of x, y, and z. So these are the very basics and very importance which you must remember. Now, your next topic is your derivative, which a part of which you have learned in class 11. And in the derivative here, we go for this product rule and quotient rule and then the chain rule. And in derivative we also go for second derivative, third derivative, second derivative, and third derivative also. And now here the formulas which you must remember here is the inverse, that is y is equal to sine inverse x, its derivative is 1 by root over 1 minus x square. Similarly, y is equal to cos inverse x, your derivative will be minus 1 by root over 1 minus x square, and y is equal to tan inverse x, your derivative will be 1 by 1 plus x square. So such inverse day, you must remember this inverse derivative. Now the most important point here is what is derivative. When a function is given to you and you find the derivative of it, that means you are finding the slope of the tangent, that is the tan, that is tan theta. And this is the very important point, that is what is derivative. It is actually geometrically it means that when you are finding out a derivative, when you are finding out derivative, that means you are finding the slope of the slope of the tangent. And by the help of, because we are able to find the slope of the tangent, we can determine whether the function is increasing or decreasing. That is, if your f dash x is greater than 0, that means your function is increasing. If your f dash x is less than 0, then it is decreasing. And by the help of which, by applying second derivative test, we can find the point of local maxima and local minima. At the same time, we can find the maximum value and the minimum value. So here, a second derivative test is given to you, but it is not necessary that you must always apply a second derivative test to find the maximum value or minimum value. By inspecting the question, you can easily determine what will be its minimum value and what will be its maximum value, whether the minimum value is there or not, or whether the maximum value is there or not. You can determine just by viewing the question or by inspecting the function. So this is all about derivatives. So in derivatives, there are no only limited formulas. You all know, that is y is equal to sine x, that is equal to differentiation is cos x. Y is equal to cos x, your differentiation is minus sine x, and y is equal to tan x, it is differentiation is sec square x, and y is equal to sec x, that is sec x tan x. So I do not want to repeat. These are the basics which you have learned in class 11 earlier. And in class 12 it will be only, that is the, you are going to apply the product rule, especially the chain rule. You, in most cases, you are going to apply the chain rule. Now the derivative, it can also be that your y, it is a function of theta, and x is also a function of theta, and then you have to find out dy by dx. This can also be done. And the most important here is application and derivative, that is the to find out the interval where it is increasing, in the interval it is increasing, or the interval where it is decreasing. So this is all about your derivative. Now integration here, integration, all the formulas which is, it is also called as antiderivative, and the formulas which is given to you, this you must remember. And apart from it, there is a different method for partial fraction, uh, for functions when integration of the product of two functions, where we are going to apply by parts. So, and substitution methods, and different integration of trigonometric functions using trigonometric formulas, which you have learned in class 11 and also in class 10. So here, when there is a product of two functions, that is we go for by parts, and we use the law ILAT, where I represents the inverse, L represents log, A represents algebra, T represents trigonometry, E represents exponential. And I'm not going to tell the basic formulas because you know about it, and these are the very basics of integration, you know about it. So only the important point here is that how and the how to solve it. You have to do a lot of practice in it. And another is the proper integration using definite integration using properties. These properties you must remember, that is P4 and P6, P7 property, which is given in your book. It is very important, and yeah, it is in your textbook. Maximum of these questions is solved by using P4, P6, and P7 properties. So this is all about integration, and the application of integration. The only application of integration, that is you have to find out the area under the curve, and to find the area under the curve, the function given to you, you must know the graph of this function. What is the graph of this function? You must know about it, and if you know the graph, you can easily find the area under the curve using definite integration. That means the lower, you will be able to find determine the lower limit and upper limit, and the area under this curve you can easily determine it. So uh, this all these pictures, everything must be clear to you, and when this is clear to you, you go on practice this, you will surely be able to succeed in NDA or JEE means, or in class 12 examination. So apart from this, there is also probability. In class 12 probability, that is conditional probability. This conditional probability is that earlier, up to class 11, from 9, you have learned probability to up to class 11. Here, the formula was probability of an event. The formula was that total number of favorable cases divided by total number of outcomes. But in class 12, it is the probability is little bit different. That is, we go for conditional probability. That means the sample space is divided into two events. And here we find the probability of an event in another event. That means, let us uh, tell you, that is a sample space, it is divided into two events, say E and F. Now we are finding the probability of E in F. This is called conditional probability, and it is written as P, probability P, E oblique F. That means, it means the probability of E when F has already occurred, and it is equal to P. This is equal to probability P, E intersection F divided by PF. So similarly, we can also find the PF oblique E, that means the probability of F in E we can find, that is probability of F when E has already occurred. Now here, next is the independent event. If the independent event is that when earlier up to class 11, you were finding the event in sample space. So the probability E oblique S, that means you are finding the probability E in the sample space is equal to PE oblique F. That means here you are finding the probability of E in F. If the both of this answer is the same, then we say that E and F are independent event, and the formula is PE dot PF is equal to PE intersection F. So in this probability, here comes the we use the De Morgan's law. It is very useful here. De Morgan's law is applicable here, and the last is the Bayes theorem. This Bayes theorem is uh, it is little bit critical, but the important here in maths, especially in maths, if you are strong in language, you can be you can easily solve this permutation combination and probability if you are strong in language. And if you are weak in language, then it becomes very difficult to solve permutation combination as well as the probability. Sorry. Now here the last is the Bayes theorem. Here the Bayes theorem is that in Bayes theorem, what is Bayes theorem? Let me explain it by the help of an example. Suppose your company is manufacturing bulbs. So today's production you have kept somewhere else. In a room you have divided into three parts. So today's in the first section it is yesterday's production, and in the second section it is today's production, and in the third section it is tomorrow's production. In yesterday's production, in your bulb you find that 5% was defective. In your today's production you found that it was 2% defective, and in tomorrow's production you found that it is 3%, there was 3% defective. Now the inspector entered into the room. He collected a bulb, say from any of these three set, and he tested it. He found that it was defective. Now you have to find that this defective is of yesterday's production. You have to find the probability that this defective is of yesterday's production. This is solved by Bayes theorem. So here, let yesterday's production event will be, let it be E1 event. Today's production it is E2 event, and tomorrow's production is E3 event, and A event is your defective. So P E1 oblique A, that is equal to P E1 dot P A by E1 divided by P E1 into P A by E1 plus P E2 into P A by E2 plus P E3 dot P A by E3. This is the formula by the help of which we solve Bayes theorem. So this is all about your class 11 and class 12 maths. Thank you.